So this is problem 582, and we're given there's a sign hanging. We know its mass is 100 kilograms, and its center of mass is at G right down here. And we're to determine the components, XYZ components of the reaction of the ball and socket joint at A, as well as the tension in cable BC and the tension in cable BD. All right, so this is a longer problem, so I'm going to break this into two parts. Okay, I'm going to first focus on solving for the reaction at A, and then in the second part we'll worry about the forces here and the tension of the wires. Okay, so by taking the moments around point B, we know that's an equilibrium, so those should be equal to 0. We see that the forces and the tension in the wires here act directly through B, so they will have no influence on the moment around B. All right. So the forces that will have influence around B here is they are the force due to the sign here, as well as the reactions at the wall A, or the ball and socket joint A. Okay. So let's first focus on the sign. All right, and we could do this keeping track of clockwise, counterclockwise motions, but in a 3D problem, it gets very confusing. So I would really focus on using the R cross F formula in terms of finding the moments of these. So let's focus on the sign G here. So the moment around B that this sign creates, we need to do R cross F. So the R vector that we're looking for, right, would be from point B to kind of the center of this pole here, because that's we could move the center of G up and it would have no influence on the moment around B. So that vector is 0 in the x direction. So if we move from B to this point here, it's 0 in the x direction. We're moving -1 because it's opposite of the way the y-axis is pointed. And it's 1 to here, so that's this dimension, -1, and then 0 moving from B to this point in the z direction as well, or the k direction. Okay, the force of the sign here at G, we know is equal to 981 downwards, which is just, if we write that as components, 0, 0, -981. Okay, so doing the cross product of R cross F here, right? And so how we do that, remember we write R, and then we write F below that, 0, 0, -981. And then we can just repeat that to make the kind of our one way of doing the cross product here. Right, so we have 1 here, and then we just repeat it here. Okay, so let's do that cross product. All right, we start here, and we multiply this times this, minus this times this. Okay. So that's -1 times 981 minus 0. So we have 981i, then this times this, minus this times this, and that's 0 times 0, minus -981 times 0, which is 0. So that's 0j. And then lastly, this times this times minus this times this, which is also 0. So we have 0k. All right. So that's the moment that this sign hanging down creates around B. All right. Now let's talk about the ball and socket joint. So we have the R vector from B to A, right? So that is 0 in the x, -2 in the y, and 0 in the k. So we have 0, -2, 0. And then our forces acting at point A, we have our AX, AY, and AZ, right? So we have AX in the I direction, AY in the J direction, and then AZ in the K direction. All right, so let's do the cross product of that. So we have 0, -2, 0, and then AX, AY, AZ, and then we'll just repeat that, 0, -2, 0, AX, AY, AZ. And let's start performing our multiplication here. So -2 times AZ minus AY times 0, and that should be -2AZ in the I direction plus 0 times AX minus AZ times 0. So that's 0 in the J. And then lastly, we have 0 times AY minus -2 times AX. And that should be positive, positive 2AX in the K. That equals 0. So now we know that if we add these two equations together, right, that's the sum of the moments, they must equal 0. So we're going to do this in X, Y, and Z components. So let's just start with the I's here. So we have 981 minus 2AZ equals 0. And solving that, we have AZ is equal to 490.5 newtons. All right, so that's one thing we were looking for in the problem. All right, in the second equation, we just look at the J's. We have 0 and 0, so we have 0 plus 0 equals 0. That doesn't tell us anything. So let's then move to the K direction. We have 0 here plus 2AX equals 0. And solving for this, we see that AX is also equal to 0. We cannot solve for AY yet, and that will come in the second part of the problem. Okay, for the second part of 582, in the first part we already solved that AX is equal to 0 and AZ equals 490.5 newtons. And so we have three unknowns left that we need to solve for: AY and the tension in both of these cables. Okay, so let's first work on transforming, since we're using kind of IJK components in this problem, let's work on transforming these tensions here into IJK components. All right, so remember how to do this. We first need to know the length of this cable here. So the cable length from BC, so we'll call that RBC. All right, and the magnitude of that, which represents the length of that cable, is in the X direction, moving from B to C, that is 1 meter. So 1 squared plus, in the Y direction, we have moving from B to C is -2 squared. And lastly, in the Z direction, moving from B to C, it is 2 up, so that is +2 squared. And then we take the square root of all that. So we have the total length is 1 squared plus 4, so it's 1 plus 4 plus 4 is the square root of 9, which is 3. And we can do that likewise for cable BD as well. All right, so finding the magnitude of cable BD. And in the X direction, we have -2, so we have -2 squared, plus in the Y direction, -2. negative 2 squared, and in the z direction we have positive 1. Take the square root of that, and that comes out to be the exact same length, which is 3 meters. Okay, so let's work on transforming, writing these forces. Although we still don't know what they are, let's work on transforming them into ijk components. So vector TBC, tension in BC, in the x direction, remember from moving from B to C in the x direction is 1. So that is 1, but we must divide that by the total length here, which up here, which is 3 TBC. And that's the I direction. And likewise, we need to do that for the J and K direction. So in the J direction, it's 2 divided by 3 TBC. And lastly, in the K direction, we have 2 over 3 TBC. Right, so we've transformed TBC into ijk components, and let's do the same for the tension in BD. All right, so we have negative 2 over 3 TBD, negative 2 over 3 TBD in the J direction. And lastly, 1 over 3 TBD and the K direction. So those are right there. Okay. So in the first part of the problem, we use moments. We could do that again in the second part of the problem, taking the moments about A if we wanted to. But let's just do sum of the forces here. So let's take the sum of the forces in the x direction, and since this is an equilibrium, it must be equal to 0. Okay. So we have, in the x direction, we have ax, which we've already found is 0. So we can write 0 there. And TBC here, in the x direction, we have plus 1/3 TBC. And TBD, we have negative 2/3 TBD. And the sign hanging here has no component in the x direction, so we don't need to worry about that. And those should be equal to 0. And through this, we find out that FBC, or TBC is equal to 2 times the tension in BD. All right, we have 2 unknowns in this equation, so we can't directly solve, but we have that relationship that we can use later. All right, let's take the sum of the forces in the y direction. Okay, we have AY, which we haven't solved for yet, and we have negative 2/3 TBC and negative 2/3 TBD, and the same as the x equation, the sign hanging has no influence on the sum of the forces in the y direction. So that is equal to 0 here. So we have 3 unknowns here. And then lastly, let's take the sum of the forces in the z direction. So we have AZ, which we know is 490.5 newtons. And then we have the downward of 981, and then also the components of TBC and TBD. So we have 490.5. The sign hanging down is 981 newtons. And then we have positive 2/3 TBC, and then a positive 1/3 TBD. And that should equal 0. So it requires a little bit of algebra here. So we can first start by taking this equation here, and we can sub 2BD in down here and solve for the tension in BD. And the tension in BD is 294.3 newtons. And that is one of our answers. Then once we have that answer, we can plug it back in up here, and we should find out that TBC is 589 newtons. Then lastly, we need to figure out AY, and AY comes out to be 589 newtons as well, right? And let's be careful about our units here, our significant figures. Let's make sure that's 294 newtons. And that should solve everything for problem 582.